Some technologies seem almost destined to play a significant role in the future of humankind, such as artificial intelligence, while others like the hoverboard appear destined to fail and be a constant disappointment. The development of new technologies is expected to radically change the world as we know it. Not all future tech ideas threaten to have as fundamental an impact as AI, but many seek to improve various elements of our lives. Want to know about it? Well, stay tuned to the video and watch the video till the end. Hello guys, welcome to Futureality. Hit the subscribe button and turn on the notifications to get new updates about technology and development. Hit the like button to show your support, and in today's video, we're going to discuss amazing technologies that will change the future. So without any further ado, let's begin. Robotic retail. Historically, robotics has turned around many industries, while a few select sectors such as grocery retail have remained largely untouched. With the use of a new robotics application called micro-fulfillment, grocery retailing will no longer look the same. The use of robotics downstream at a hyper-local level will disrupt this 100-year-old, $5 trillion industry, and all its stakeholders will experience significant change. Retailers will operate at a higher order of magnitude on productivity, which will, in turn, result in positive and enticing returns in the online grocery business. This technology also unlocks broader access to food and a better customer proposition to consumers at large, speed, product availability, and cost. Micro-fulfillment centers are located in existing real estate at the store level and can operate 5 to 10% more cheaply than a brick-and-mortar store. Brain-computer interface (BCI). A brain-computer interface, sometimes called a neutral control interface, mind-machine interface, direct neural interface, or a brain-machine interface, is a direct communication pathway between an enhanced or wired brain and an external device. Beyond obvious and needed work in the prosthetic space, it's the medical aspect that would be most transformative. A chip implemented in the brain could help prevent motion sickness, could detect and diagnose cancer cells, and help with the rehabilitation of stroke victims. It could also be used for marketing, entertainment, and education purposes, but let's not get ahead of ourselves. There are currently dozens if not hundreds of technical challenges to wrestle with before getting anywhere near something that an average person could see. First and foremost, need to find the right material that would not corrode and or hurt the brain after a few weeks, and get a better understanding of how the brain actually works. Self-driving vehicles and drones. Companies like Apple, Google, and Tesla have been working on self-driving cars for years. It's safe to say that the whole process is based on trial and error, but their progress is definitely impressive. For so long, drones, air taxis, and all-electric aircraft had occupied the same cultural territory as hoverboards, teleportation devices, and warp speed, in other words, science fiction rather than science fact. While the idea of a world where workers commute by on-demand air taxi and towns and cities of the UK are linked by electric and autonomous flight may seem far-fetched, it's actually just around the corner. While some industries are already beginning to experience just a small fraction of the benefits that this new era of aviation has to offer, once established, this technology has the potential to totally revolutionize the way society operates. Artificial eyes. Scientists have developed an artificial eye that could provide a vision for humanoid robots or even function as a bionic eye for visually impaired people in the future. Scientists have spent decades trying to replicate the structure and clarity of a biological eye. The key feature allowing such breakthroughs is a 3D artificial retina made of an array of nanowire light sensors that mimic the photoreceptors in human retinas. Developed by Professor Fan Ziyong and Dr. Gu Leli from the Department of Electronics and Computer Engineering at HCUST, the team connected the nanowire light sensors to a bundle of liquid metal wires serving as nerves behind the human-made hemispherical retina during the experiment and successfully replicated the visual signal transmission to reflect what the eye sees onto the computer screen. Energy storing bricks. Researchers have managed to store energy in the cheap red bricks we've been using for construction throughout the world for centuries. This process works for two reasons. Bricks are porous and contain something called hematite, which gives it its color. For these bricks to store and then release energy, researchers heat them to 160 degrees and vaporize their surface with hydrochloric acid mixed with an organic compound called EDOT. The main benefit of this technology of the future would come about when used at a house equipped with solar panels. The bricks could then store unused electricity and then compensate for the intermittence of this renewable energy. This would make our homes more self-sufficient in energy and less dependent on electric cables and or the likes of lithium batteries. Medical capsule. A new generation of tech-enabled pills is aiming to help measure adherence in people taking medicines regularly. When the patient swallows the pill and it hits their stomach, the acid environment activates the pill's onboard sensor. The pill then signals to a wearable patch or lanyard that the medication has been taken. The first sensor-packing pill to be approved was Abilify Mycide, which contains aripiprazole, a medicine for a psychiatric condition like bipolar disorder and schizophrenia. When Abilify mycite is swallowed, the pill sensor communicates that status via Bluetooth to a chest-worn patch, which then lets a smartphone app know the pill is taken. The system can also be used to record other factors such as the user's activity and rest times. Data gathered by the system can be for the user's own information or shared with their doctor or caregivers, such as family or friends. Color-changing sutures. Dacia Taylor has juiced about 3 dozen beets in the last 18 months. The root vegetables she's found provide the perfect dye for her invention, suture thread that changes color from bright red to dark purple when a surgical wound becomes infected. The 17-year-old student in Iowa City West High School in Iowa City began working on the project in October 2019 after her chemistry teacher shared information about statewide science fairs with the class. As she developed her sutures, she nabbed awards at several regional science fairs before advancing to the national stage. Taylor had read about sutures coated with a conductive material that can sense the status of a wound by changes in electrical resistance and relay that information to the smartphones or computers of patients and doctors. While these smart sutures could help in the United States, the expensive tool might be less applicable to people in developing countries, where internet access and mobile technology are sometimes lacking. Haptic virtual reality. Haptic devices can be grouped into 3 main types: graspable, wearable, and touchable. One clear application is in the operation of robots so that an operator can feel how much resistance the robot is pushing against. Take surgical robots, which allow doctors to operate from the other side of the world or to manipulate tools to small or in spaces too tight for their hands. Numerous studies have shown that adding haptic feedback to the control of these robots increases accuracy and reduces tissue damage and operation time. Ones with haptic feedback also allow doctors to train on patients that exist only in virtual reality while getting the feeling of actual cutting and suturing. Getting a feel for what the robot under your command is doing would also be helpful for defusing bombs or extracting people from collapsed buildings. Floating farms. The Barcelona firm's design comprises a multi-level agricultural barge that can be constructed, pushed out to sea, and left to work mostly on its own. The farm is designed to operate on 3 levels: a bottom level containing wave barriers, an aquaculture fish farm, a slaughterhouse, a packing facility, and a desalination plant, a second tier for hydroponic and aeroponic food production, and a rooftop level featuring skylights to let in light and photovoltaics to provide the energy required to power everything. At 656 by 1150 feet, each level is approximately 750,000 square feet, enough room to grow up to 8.1 tons of vegetables and 1.7 tons of fish per year. The architects estimate that this would cover the project's expenses within 10 years. Now that we've come to the end of this video, I want to thank you for sticking with me, and I'd love to know what you think of it. Just comment down below. Also, if you like this video, make sure you like it and stay safe. Today's video is over, but if you want to see more, there's one on your screen right now, and there are a few more fun videos coming soon. I'll see you in the next video.